Here we have AP calculus AB problem. Okay, let's go to the question. Integral pi over 4 to pi over 3 secant square theta divided by tan theta d theta equals to. Here we have a definite integral. We have to evaluate the value of this definite integral. Okay, now what I'm going to do is I'm going to consider the given integral as if it were an indefinite integral. So once I get the result of the indefinite integral, then I'll apply the pi. Indefinite integral means like we have to consider the given integration without the limits we have over here. Okay, now let me consider the given integration as an indefinite integral. That is integral secant square theta divided by tangent theta d theta. Okay, now let's get the result of this integration. Okay, how do you have to integrate the function we have over here? I'm going to use method of substitution to integrate the function we have over here. And here you may have a question. As soon as I see this integration, how can I decide that we have to use the method of substitution? Because when I consider this particular part, tangent theta, what is the derivative of this tangent theta? That is secant square theta, that's over here. In the given integrand, we have the derivative of a particular part is in the integrand itself. And also we will be able to multiply this derivative secant square theta with d theta. So whenever we have the derivative of a part of the integrand is multiplied in the integrand itself, and if we are able to write the derivative along with d theta, I mean the dx or whatever it is, using multiplication, we can use the method of substitution. So now what I'm going to do is I'm going to write the given integration over here as 1 over tangent theta. Since secant square theta is a derivative of tangent theta, let me write this one along with d theta. Then I'm getting secant square theta times d theta. Okay, for which part do we have derivative? For this part, for tangent theta we have derivative, it's secant square theta. So the part for which we have derivative, we have to substitute a new variable. That is, let me substitute a new variable u for this particular part, tangent theta. Now I have to, since I have substituted new variable u for tangent theta, I have to get this complete integration in terms of the new variable u. In that case, instead of d theta, I must be getting du, so that I'll be able to integrate with respect to u. Okay, if I want to get a du at the place of d theta, what should I do with this u? I have to find derivative. And also u is a function of theta. Since u is a function of theta, let me find derivative on both sides with respect to theta. When I find derivative of this u with respect to theta, I am getting du over d theta. On the right side, when I find derivative of this tangent theta, I am getting secant square theta. Now let me multiply both sides by d theta. When I do so, this d theta will cancel out. Then I'm getting du equals to secant square theta times d theta. Okay, now we can write this integration as 1 over, for this tangent theta, we can substitute the new variable u. And for this secant square theta d theta, we can write du. So to make the integration process easier, we apply this kind of methods. Like in this one, I just applied method of substitution. Just look at the original integration and look at the integration we have after the method of substitution. Now let's consider a particular formula in integration, that is integral. I mean, it's a particular property of integration, f prime of x divided by f of x dx. Okay, now let's consider this integration. Here in denominator we have f of x. What is the derivative of f of x? It's f prime of x. So the derivative of the denominator is in numerator. In integration, whenever the derivative of the denominator is in numerator, so its result is a natural logarithm of what we have in denominator, that is f of x positive c. Okay, now let's consider this integration. So here we integrate this stuff with respect to u. Now let me consider the denominator, that's u. When I find derivative of this u with respect to u, what do you get? I get 1. So the derivative of the denominator u with respect to u is in numerator. So that is, it's exactly in this form. So what result should I write for this one? I have to write natural logarithm of denominator. What's the denominator we have over here? That is u positive c. Here I have the constant of integration c, because we are evaluating indefinite integral. Whenever I am trying to get the result of an indefinite integral, so once I get the result, I must add constant of integration. If it is definite integral, that the constant of integration c is not required. Okay, anyways, ln of, actually u is a variable taken by us. Now it has to be replaced by the original stuff, that is tangent theta. Then I am getting ln of tangent theta positive c. Okay, now I got the result of this indefinite integral. The result of this indefinite integral equals to natural logarithm of tangent theta positive c. Okay, now let me erase the stuff and continue the problem. Here I have written the result we got from the previous work, that is the result of this indefinite integral equals to natural logarithm of tangent theta positive c. But when I consider the given integration, it's not an indefinite integral, it's a definite integral, that is we have the limits pi over 4 and pi over 3. Let me take the limits over here, pi over 4 and pi over 3. Since it becomes a definite integral, we can ignore the constant of integration c. And now for this result, I mean the result on the right side also, we have to take the same limits, that is pi over 4 and pi over 3. Okay, now what I have to do is I have to plug in these limits for the result over here. Actually, these are the limits for theta, because here we integrate with respect to theta. So whenever we have d theta, the variable we have to consider over here, for which we have these limits. Okay, now in this result, first we have to apply the upper limit, that is pi over 3 for theta over here. Then I'm getting ln of tangent pi over 3, and now I have to take negative sign. In the same result, I have to apply the lower limit, that is I have to plug in this pi over 4 for theta over here. Then I'm getting ln of tangent pi over 4. Okay, so natural logarithm of, okay, pi over 3 radians is 60 degrees, tangent 60 degrees equals to square root of 3. That we have to remember, negative ln of, and pi over 4 means it's 45 degrees, tangent 45 degrees is 1, and ln of square root of 3 negative. So for any logarithm, if the argument is 1, its value is 0. Finally, we get ln of square root of 3. So now I just got evaluated the given definite integral. So it is equal to natural logarithm of square root of 3. We find this stuff in answer choice B. The correct answer choice for this question is B.